As I have said on my last lecture, that my next session will be on normal forms. So, normal forms are categorized into two forms, that is conjunctive normal form and disjunctive normal form. And today I am starting with conjunctive normal form. Now I am starting with conjunctive normal form or CNF. A compound proposition P is said to be conjunctive normal form of R simple propositions P1, P2, Pr, where each Pi is equal to disjunction of a finite number of the simple propositions or their negations. Each Pi means this P1. This P1 is equal to disjunction of a finite number of the simple propositions or their negations for all distinct I and j, or for all different ij, like where Pi is not equal to Pj. So this is conjunctive normal form. So let me take you to the example. Like see, here P is equal to negation of P1, disjunction P3, negation P2. Like conjunction with negation of P1, disjunction to negation of P2, disjunction to negation of P3, conjunction with P1, disjunction P2, disjunction P3. And this statement or proposition is a CNF of the simple propositions P1, P2 and P3, because this proposition or statement actually following the CNF formula what I already have said. Like now the next example, P is equal to negation of P1, disjunction to P2, conjunction to negation of P1, disjunction negation of P2, disjunction P3 is not a CNF since the expression negation of P1 disjunction to P2 doesn't contain P3 or its negation. Because from the explanation of CNF, we have come to know that each Pi is equal to disjunction of a finite number of the simple propositions or their negations. So here the P3 or its negation is missing from the first proposition. So this is not following the conjunctive normal form rule. And now disjunctive normal form. So a compound proposition P is said to be disjunctive normal form or DNF of R simple propositions P1, P2, P3, Pr if the expression P can be expressed as P is equal to P1 disjunction to P2 disjunction to Pn, where each Pi is conjunction of some of the simple propositions or their negations without any repetitions, and no Pi is contained in any Pj where j not equals to I. So here is an example of disjunctive normal form. So P is equal to P conjunction to negation of R, disjunction to negation of Q, conjunction P, conjunction R, disjunction to negation of P, conjunction negation of Q is a DNF. So this is the form which is following the disjunctive normal form rule. like where each pi is conjunction of the simple propositions like PR or their negations like negation of R, negation of Q without any repetitions, and no pi is contained in any PJ. So this is the DNF example. But P conjunction to negation of R, disjunction to P conjunction to negation of Q, conjunction to R, disjunction to negation of R, conjunction P conjunction Q is not a DNF since P1 is equal to P conjunction negation of R is contained in P3 is equal to negation of R conjunction to P conjunction to Q is equal to P conjunction to negation of R conjunction to Q is equal to P conjunction to negation of R conjunction Q. So this is P1 which is contained in P3. So this is not following the DNF rule. So this is not DNF. And now arguments. Deduction of a proposition Q from a set of propositions P1, P2, Pn. It can be compound or simple, is called argument. Symbolically, we write P1, P2, Pn is deducted to or concluded to Q. So P1, P2, Pn are called premises and Q is conclusion. So this is the arguments. So now valid argument. An argument P1, P2, Pn deducted to Q or concluded to Q is called valid argument if P1 conjunction to P2 conjunction to conjunction Pn implies Q is a tautology. So then that would be a valid argument. And now predicate. Let x greater than 8 where nature of the x is described by the set of words greater than 8. So x is subject and greater than 8 is predicate. So let me give you an example. Let px is a propositional function of the variable x. For any value of x, it is proposition. So if x is equal to 3.7, then p of 3.7 is the proposition 3.7 greater than 8, which is false. So the truth value of this proposition p of 3.7 is false. Now this is domain or universe of discourse of a proposition function, the set of all possible values that may be substituted in place of the variables of a proposition function is called domain of the proposition function. It is not necessary that p of x will be true for all values of x in the domain. So let me give you an example where p of x is x greater than 8. We may think x assumes the value from the set A is equal to 1, 2, 9 and 10. then A becomes universe of discourse. Here P of 1 and P of 2 are false, cause where P of 1 then x is 1, so 1 is not greater than 8 and 2 is also not greater than 8, so these two proposition function are false, while P of 9 and P of 10 are true. So this is universe of discourse or domain.